Thank you all for coming to the SOLIDWORKS Simulation 2021 What's New? Easier, Better, Faster. My name is Shaun Bentley. I'm a simulation specialist. Been with GoEngineer for a couple years and with SOLIDWORKS for roughly 15 years now. And with me I have Erick Vega. Erick, would you like to introduce yourself?
Hello everyone, my name is Erick Vega. I am a simulation specialist. I've been with GoEngineer for 4 years now. And today we want to cover all of the What's New 2021 features included in the simulation package.
The main focus this year was to make SOLIDWORKS simulation faster and easier to use. I'll start by discussing enhancements to meshing, such as the faster blended mesher and a mesh quality tool to help speed up your simulations. Then I'll discuss some of the bonded and contact improvements to make them easier to run. Then I'll turn it over to Erick, who will cover the faster FFE solver and some post-processing improvements that will make it faster and easier for users to get the answers they need. Since many of the enhancements in SOLIDWORKS Simulation 2021 are focused around the mesher, it may be best for me to review the types of meshers and also different mesh quality metrics. In SOLIDWORKS Simulation 2021, we've changed the order of the default meshers. You see in SOLIDWORKS 2020, the standard mesh is the first one on our list. However, we've flipped the order, recommending the blended curvature-based mesher, which has received a couple enhancements this year. Since many users may not have used this mesher in the past, let's talk about the different meshing styles. In this example, I'm going to create a mesh on a surface that has a tiny pinhole in it, on which I've applied a mesh control. And we'll observe mesh quality differences between the standard, curvature-based, and blended curvature-based meshers. What we'll be looking at in the subsequent slides is this quality metric we call aspect ratio. Good quality elements look like this equilateral triangle on the right. Bad quality elements are long and slender, like this one here. Aspect ratio is just one of several metrics that we sometimes use to judge general quality of a mesh. With the standard mesh, we see some good quality elements, but near where I've applied the mesh control, the elements get squeezed and scrunched. Compare this to the curvature-based mesh, where it balances things a little better. We don't see as many very high aspect ratio elements, as many white ones, but we don't see very many black ones either. With the blended curvature-based mesh, the aspect ratios are much, much better. It's almost a night and day difference between the blended curvature-based mesh and the old curvature-based one. Why it's advantageous for a mesher to focus on good aspect ratios is to give us more consistent mesh flow. You can see what mesh flow can do to your results. In this region, we have nice, even 2 elements through the thickness, and you can see the results are nice and smooth. However, in this region, you can see the elements get misaligned, and so the results end up getting a little fuzzy here. Here too, if we do a comparison between the standard mesher, you see the mesh alignment doesn't look so good in some areas. Looking at the curvature-based mesh, we see some of the same issues. Pretty good alignment in some regions, and it seems to generally misalign in others. But as it's always been with the blended curvature-based mesh, it gives us very good alignment all the way across the geometry. So far I haven't covered anything new with the blended curvature-based mesh, so why don't we see more people using it? One of the reasons is it's a lot slower to use the blended curvature-based mesh. However, in SOLIDWORKS Simulation 2021, that mesh has gotten a lot faster. To show you this speed improvement, I've tested this mesher on 3 different pieces of geometry ranging from very simple to very complex. In the first case, I meshed a simple cube to see how much faster it is at meshing blocky volumes. In SOLIDWORKS 2020, it took about 15 seconds to get about 300,000 elements. In 2021, it took only about 7 seconds to get the same. This next piece of geometry is very thin plate that has a lot of tiny ribs on it, little tiny fillets on the sketch text. This can pose a lot of trouble for many meshers. I tried to find the coarsest mesh I could get to work in both versions, and in SOLIDWORKS 2020 it took 89 seconds to mesh it, versus in 2021, 37 seconds. I also tested this with much finer, better quality meshes on both instances and saw a similar performance improvement. Finally, on this last piece of geometry, I wanted to test how much the curvature played a role in slowing down the meshers. In 2020, it took 25 seconds, and in 2021, this one only took 9. In summary, the blended mesher seemed to be about 2 to 3 times faster this year than it was in the 2020 release. It's interesting to note that in the 2021 PDF, their claim is that the mesher was approximately 15 times faster. But I think this must be a mistake because I couldn't get anywhere near this time. For example, how long do you think it would take this assembly to mesh? Do you believe in 2020 that it took 7.5 minutes to get 46,000 nodes? What I think happened here is that in 2020, you used to get a message that would pop up. They may have left that message on the screen, which keeps this counter running on accident. Still, with it being at least 2 to 3 times faster, that brings the meshing time down close to what we expect out of the other meshers. One of the reasons for this drastically faster meshing in 2021 is we've broken up the meshing process into multiple processes to really take advantage of multiple processors. During the surface meshing phase, you might see this process popping up, taking up some of your CPU. And then during the volume meshing phase, which happens after 50%, you might see this process. One of the side benefits of having these separate processes is it makes this cancel button a bit more robust. Have you ever clicked the cancel button before and then got this message, terminating mesh, please wait? So far, in most of my testing, this cancel button has been much more responsive. The next new tool I'd like to talk about in SOLIDWORKS Simulation 2021 is called the Mesh Quality Diagnostics. In SOLIDWORKS 2020, it was difficult to track down elements that have bad aspect ratios. Can you find them in this picture? They're the red ones. Now in Simulation 2021, you can isolate those poor quality elements using the Mesh Quality Diagnostics tool, making them much easier to track down. This quality diagnostic plot can be added to your mesh default plots, which is also brand new. Let's show a demonstration of these couple of features. In this pair of vice scripts, I've already set up my loads, fixtures, and connections. Now I'd like to take a look at a mesh. In SOLIDWORKS Simulation 2021, I can set some default options for how my mesh will be displayed. Initially, the mesh will be displayed the same way it was in previous releases. However, here I'll add a new plot that will show me a contour plot of aspect ratios. While I'm in here, I'll add another new plot that'll do a mesh diagnostics on those same aspect ratios. So now, when I create a mesh, using the faster blended curvature-based mesh, right away I can see where some of my mesh quality issues might be located. Over here you can see the 3 plots that I asked for, the mesh, the aspect ratio contours, which I'll add a legend to, so that we can look for aspect ratios greater than, let's say, 10, or the diagnostics tool, which isolates by default any elements that are greater than 20 aspect ratio. Here too I'll ask for anything that's greater than 10. This tool also contains a built-in mesh helper, which gives me some advice on how I can improve mesh quality. The first suggestion it states is, for each part, use the geometry analysis tool. This tool is great for tracking down sliver faces and tiny edges, but there's nothing new here. The second suggestion says to adjust the global mesh, and it gives me a shortcut down here to do that. And the third button says I can add mesh controls to necessary faces and edges using a table, and that's what this button does. What this table shows is all of the edges and faces that have a bad mesh quality element associated with it. And it allows you to apply mesh controls automatically to those same faces and edges. Generally, I don't recommend using this tool in this manner, unless there's only a couple of faces or edges that you want to correct. Since there are so many faces and edges in here, what we'll do is we'll filter this list down by first telling it which component I'm interested in. I'll tell this plot to only show on this top arm body. That's the one I'm most interested in calculating the stress on. And next we'll apply a globally finer mesh to try to improve some of our mesh quality. At this point, if I'd like to do further refinements, I'll probe and diagnose my aspect ratio plot to enter this mesh helper once again. And now the list is much smaller as far as how many edges and faces still have issues. From here we could select a particular face that I know I want to refine, and then see what our new mesh looks like on this face. It's nice to see this auto mesh control. If I go ahead and create a new mesh, you can see it's pretty conservative in the size that it decides to use. This can be adjusted. It's just another mesh control in the list. So if you did want to use a bigger size, you can come in here and change it. What kind of difference does it make to our results if we don't improve some of the mesh quality in some of these regions? Here was one of those regions that had poor mesh quality. You can see the discontinuity in the stress profile going across what looks like to be a bit of an edge, and also a bit of a stress spike in this region where one of these elements collapses. If we track down those regions, improve the mesh in that region, and compare the results from before and after, you can see the results look much smoother and we don't get that same little stress spike that happens here. Now you may only want to adjust the mesh quality in regions where you're really interested in calculating stresses, because that'll be the most important place to make sure that you get high accuracy. So with the new Mesh Quality Diagnostics tool in SOLIDWORKS Simulation 2021, it makes it easier to track down mesh quality issues in some of the regions where you may be most concerned about stresses. There's also a new quality metric available with shell elements called Skewness. Equilateral elements like this one here have a skewness of 0, they're ideal, but some elements in your shell meshes might get a bit skewed. Here's one that has a skewness of about 0.5. Skewness varies from 0 to 1 and is based upon this equation here. But basically it comes down to the angles that are within each shell element. With all angles at 60, your skewness is 0. If any of your angles are 120 degrees, your skewness will drop to 0.5. If you theoretically have an angle all the way up to 180, then your skewness would be 1. But skewness is always less than 1 because you never have a triangle with a 180 degree angle in it. A similar kind of trend if you go smaller as well. 30 degrees gives you a skewness of 0.5, as well as a theoretical 0 degree angle gives you a skewness of 1. So the idea is to try to minimize skewness in order to ensure best mesh quality. So with the Mesh Quality Diagnostics tool, it makes it easier to track down problematic elements, and we also offer a new skewness metric for shell elements. Some new default options have been added in Simulation 2021. Now you can have the blended curvature-based mesh as your default if you would like. And we added this option, Mesh All Solid Bodies with Solid Mesh. What does this option do? If you've ever meshed an assembly that contained some sheet metal parts, some weldments, and some solid bodies, your simulation tree may have looked like this, with the sheet metal parts being meshed with shell elements, the weldment parts being meshed with beam elements, and everything else being meshed with solid elements. This was a bit confusing for new users since they'd have to be proficient at bonding beams to solids, beams to shells, shells to solids, and so on. So when you enable this default option, it just meshes everything, sheet metal body, weldment body, or simple solids, using solid elements. We've also added this option so that you can quickly tell all those sheet metal and weldment bodies to be treated as solid, or tell all those sheet metal and weldment bodies that are already solid to be treated back as a beam or a shell again. Next, let's move on to some of the changes that's taken place to contact in SOLIDWORKS Simulation 2021. If we edit the global contact in Simulation 2020, you might be familiar with this property manager. See how it's changed in 2021. First, what you might notice is that we've changed some of the names to be more in line with industry standard terminology. Instead of no penetration and allow penetration, we've changed that to contact and free, respectively. Since now we're using the word contact to describe a specific no penetration or sliding type of contact, we changed everywhere else where we see the word contact, where it says component contact and contact type, we changed that word to interaction. Interaction type and component interaction. You can see some of those same changes here where we had contact sets and component contacts, local contacts. They've all been changed to the word interaction instead. Another big change is how we handle gap bonding, which I'll have some more slides for later. And now instead of having a compatible mesh, incompatible mesh radio button, we simply call it enforce common nodes between touching boundaries when you want to make the mesh compatible, and it's now a checkbox. And finally, this bonding formulation section is similar to what we had in the study properties, with simplified being the node to surface option, and then the more accurate being similar to the surface option that I have selected here. However, there's been some enhancements to the surface to surface option, which I'll also go over in the subsequent slides. In past releases, we really wanted users to use a lot of compatible meshing when possible. This generally gave better stress results in the touching regions because that way we can merge the nodes of one body to the nodes of the next. However, accomplishing this could be very tedious because it required users to have very clean models where all the faces touched nice and perfectly so that we could get this nodal alignment. Also, it made meshing assemblies more complicated because now instead of just meshing each part independently, we had to mesh all the parts together to make sure we could get that nodal alignment. In Simulation 2021, we encourage users to try out the incompatible mesh, or in other words, to leave the checkbox turned off for enforcing common nodes between touching boundaries, because we've enhanced some of the bonding that happens between independent meshes. This makes it easier to mesh your assemblies because we can have one thread meshing this body, a separate thread of your processor meshing this one, and a separate one meshing this body. And it makes it easier for users to set up their studies because now they don't have to worry about making sure faces line up perfectly anymore. We can have small gaps and treat it rather robustly. With some of the improved bonding that happens in Simulation 2021, it makes this possible. For example, take a look at this comparison between Simulation 2020 on the left and 2021 on the right. This table shows the consistency in bonding that you get with the new Simulation 2021 compatible meshes compared to 2020. You can see a big difference between when faces touch versus when I add a tiny gap of 1/1000th of an inch. There's a big difference in the results that you get in Simulation 2020. Right in this region here, you can see that the bonding doesn't occur between these very coarse elements. But in 2021, you see the bonding is more consistent between when the bodies are touching, and when we didn't have them perfectly modeled, they have a small gap between them. In this scenario, I'll show a variable gap that starts with 0.1 millimeter and goes up to 3 millimeter. In 2020, I can set up non-touching faces and tell it to bond anything less than 1.5 millimeter. I'll set a similar setting in 2021. Gap range for bonding equals 1.5 millimeter. And what do the results look like? In 2020, the bonding doesn't occur unless the faces are parallel to one another. But in 2021, it goes ahead and takes care of that for me. Another big advantage in 2021 is it'll even bond together where there's overlap between bodies. With the same 1.5 millimeter keyed in, it looks to me like it's bonding about halfway to the edge here and halfway to the edge there as well, based on how the stress flows through this body. I tested out many other types of surfaces like spheres, toruses, and even some spliner ones, and they all seem to work pretty well. In 2021, we've added some new defaults to the contact section. Remember, we've named it to interaction. And in 2021, you can finally change the default global interaction. Instead of being always bonded, you can set it to free, or even formerly called no penetration. You can change it to contact. Also, you can set these gap ranges. By default, it'll bond together if two faces are within 0.01% of the characteristic length of each other. And similar defaults for a gap range for the contact or no penetration sliding contact. But this one's set to be, of course, much greater at 10% of the characteristic length. You might wonder, what is characteristic length? That's simply just referring to the longest diagonal in your model. Here's an example that shows if I set this to 100%, it measures 548.63. Well, if I were to draw a box around my model and measure that long diagonal, exactly the same metric is used there. So in other words, if the long diagonal of your model is 100 millimeters, this is going to bond together surfaces that are in the order of 0.01 millimeter away from each other. But it'll make sure it generates contact elements if those same surfaces are within 10 millimeters of each other. So with the improved bonding in SOLIDWORKS Simulation 2021, it should make it a lot easier to run simulations on bigger models with a lot less manual cleanup. Another interaction change in SOLIDWORKS Simulation 2021 is an improvement on the contact through the use of contact correction factors. If I mesh this body with a draft quality mesh or a high quality mesh, it can mean very different results for contact problems. With contact correction factors, Simulation 2021 will look at the actual surface that these elements are mapped onto, in this case a cylinder, and it'll apply a correction factor to the contact to account for differences between the mesh and the geometry. The correction factors will usually have a much bigger impact on draft quality meshes than they'll have on high quality meshes, since the high quality mesh matches the surface usually a lot more closely. These correction factors work on conical, cylindrical, or spherical faces only. To test these correction factors, I've created a spherical ball and fitted into a spherical hole, and also used different gap sizes. Here we have 0.02 of an inch gap between the diameter of the ball and the diameter of the cup that it fits in. Here, a 1,000th of an inch, and here they're contacting each other perfectly. When I use draft quality elements in Simulation 2020, you can see the results are a little bit spotty, especially in these two scenarios. But in 2021, due to the correction factors, the contact results look a lot smoother in all three cases. With a high quality mesh, there seems to be a little less difference between 2020 and 2021. Interestingly, this case had a little bit of this sort of sawtooth pattern, and you can kind of see here a little bit of contact being generated up here, whereas in 2021 with the correction factors, it's hardly any to be seen. Looking at a close-up of the 2020 draft quality mesh and comparing that to the 2021, you can see the difference a little more clearly here. So now in SOLIDWORKS Simulation 2021, we should be able to handle contact problems more accurately than what you could in 2020 and previous releases. At this point, I'll turn it over to Erick Vega, who will talk about the solver, post-processing, and a few other enhancements.
To keep covering the rest of the What's New 2021 for simulation, we actually have some improvements in the solvers, the FFE Plus in particular. We have improved post-processing for very large models with 2 million elements and more. There's a couple of new options and features in the simulation evaluator, and we also have the ability to now copy tabular results to clipboard from the probe or the list resultant forces option. To test the FFE Plus solver improvement, I ended up running this model. It's just a little chair with a pretty high density mesh. I ended up actually using the worst practices that we could think of, just to be able to make it be very unstable. Overall, with the mesh controls on the faces that have no penetration contact, we ended up getting 170,000-ish elements, 888,000 degrees of freedom, and 45,000-ish contacting elements, which is about 26% of the entire study. So just to give you a better idea of how the contact was set up, the no penetration contact here can be seen on the right plane slide on the bottom. We have a pretty high density mesh in there. Okay, on the front plane, which is the section B on top, you can see that quite a bit of that mass on top, which was said to be aluminum, was actually making contact. So to test this out, what we did is we set up some fixtures on the feet, just turned on gravity, added friction of 0.05, and did not restrain that mass on top. And we just let the FFE Plus solver run. So for my results, turns out 2020 in a 6-core Xeon processor running at 4 gigahertz, it ended up taking 3 hours and 17 minutes. Now, I ended up doing the same test on another computer, running the 2021 test on another computer, a 4-core i7 running at 3.5 gigahertz, and that actually took a lot less time, significantly less time, only 23 minutes. I was honestly surprised, but it works out great. It actually has made a pretty big difference in a whole bunch of other different tests that I've done. I'm just very glad that I can actually stand by this. It does a pretty good job. Next, we also have improved displays. If you've ever had the chance to have a massive study and then seen spotting in your plots after you run your study, well, 2021 has actually taken care of that problem. It doesn't show anymore. Next, for the simulation evaluator, if we right-click the study name and select simulation evaluator, we now have a couple of extra options that we did not have before. If you guys haven't used the 2020 simulation evaluator that was added, you should check it out. It has a few nifty features in it. But here in 2021, we now have the ability to actually validate or relink the CWR results file to a rogue or disconnected SOLIDWORKS file. Here we actually have the option to link it essentially, and then we also have the ability to quickly test and see if any of the friction coefficients that may have been added to your no penetration contacts, maybe higher than 0.2, which usually has trouble converging. And then last, we now have the ability to copy the results that you actually get in the plot. So when you are in the probe property manager or the list forces manager, you now have the option to copy to clipboard. So now you'll be able to actually copy all of this data and then bring it into whatever spreadsheet application you are going to use to post-process that data a bit more. That's just about it for the Simulation 2021 content that we have. But before I let you go, I want to remind you, if you want to sign up for the live virtual webinars in case you have more questions regarding simulation, please go into our website, GoEngineer.com, where you'll have a link for the 2021 What's New sign-up sheet. So if you go into GoEngineer.com, on our homepage, you'll have the Learn More option. Click into it, and here you'll have the ability to sign up for the different topics that we will be presenting in our live virtual webinars. Well, thank you guys for coming. We'll see you at the What's New 2021 release.